Good afternoon, all of you. Am I audible?
Yes, ma'am.
Okay. And tell me whether the screen is also visible to you.
Yes, ma'am.
Okay. Right. So let us start with the lecture. In the previous lecture, we have started with the chapter number 3, unit number 3, that is transformations. So here we are going to learn 2D and 3D transformations as we have earlier discussion on it. So in 2D transformations, we are going to learn translation, scaling, rotation, reflection, etc. Out of that, in the previous lecture, we have seen the first part, that is 2D translation. So let us revise it in 1 minute. So translation is nothing but a process of changing the position of the object in a straight line path from one coordinate location to another. So here we are going to shift the object from its from its original position to a new position where the size and shape of the object remains same, only we are changing the coordinates. So earlier coordinate xy will become x dash y dash, where x dash and x has some relation between them, and that is nothing but the translation factor along x-axis. So we know when we add x and tx, we are getting x dash. Similarly, when we add y and ty, then we will get y dash. So you should know by how much amount the object is shifted in x direction as well as in y direction, and that forms your tx and ty respectively. Okay, so translation is simply shifting the object, so its all size and shape will remain constant and coordinates will only change, and those change in the coordinates is by a tx and ty distance along x and y axis respectively. Okay, then we have seen the in matrix form. So simple matrix form is, if I want to get x dash and y dash, then I will add x with tx and y with ty. So the easy expression is p dash is equal to p plus t, but it actually is not giving you the actual result, or every time you have to consider pixel by pixel. Instead of that, what we can do is we are going to make use of homogeneous coordinate system, in which a two-dimensional entity is represented in 3 by 3 matrix. Right. So if you remember, we are having the two-dimensional entity, this triangle ABC. So instead of x and y coordinates, we have added a third coordinate, and that is called as homogeneous coordinate. So we have represented this A point as 10, 10, 1. Right? If you remember in the matrix, how we have represented A, it is its x coordinate, its y coordinate, and the homogeneous coordinate value 1. Then we are having the 20, 10, and again 1. And the third coordinate is 15, 20, and 1. So we are having this representation for a triangle. And when we multiply it with t, so this is your original p that you have written right now. Then what comes next is t, that is the translation matrix. So in translation matrix, we are having the what we can say identity matrix or unit matrix of 3 by 3 size. So here we are going to have a 3 by 3 matrix, where it is a unit kind of matrix. Only 2 elements are changed, and that are with respect to your x translation and y translation. So this gives you the translation matrix. And when we perform the multiplication between these two, then I will get a result. And what is the order of that result? This is your original P matrix. What is the order of this P matrix? It is 3 by 3. 3 rows and 3 columns. Similarly, this T is also 3 by 3. So what is the ultimate value of P dash that we are going to get is P dash will also become 3 by 3. So P dash is also 3 by 3, where the last element is always 1 or last column is always 1 because it is a homogeneous coordinate system. And these two will represent x1 dash, y1 dash. These two will be representing x2 dash, y2 dash, and these two will represent x3 dash, y3 dash. Okay, so this is the resultant triangle you will get after translation. Okay, is there any difficulty up to this point, girls? Is there any difficulty up to this particular point? Yes, reply fast. Boys side.
No, ma'am.
Okay.
Hello, ma'am.
Yes.
Ma'am, can you send these PPTs?
Okay, I will, because the last part is still under modification, because whenever I am getting the new and good examples, I am always making changes in my PPTs. So I'm not sending, but if you wish, I can send it today itself after lecture. Okay.
Okay, thank you.
The remaining first two chapters already you are having the PPTs. So
Yes, ma'am.
yeah. So this chapter also I will send, and again the modified version I will send later if I will make any changes in these PPTs rather. Okay. So this was about the translation. So 2D translation. And next operation or next transformation we are going to learn today is rotation. So I believe in translation there is no doubt. So we will start with the 2D rotation. So what comes in your mind when I say rotation? What comes in your mind when I say rotation? Okay. So rotation is nothing but simply turning the object about a specific point. For example, if we are taking the example of a clock, then the hands of the clock, maybe it is a second hand or a minute hand or hour hand. So the hands of the clock are moving around the center of the clock, around the center of the clock where all hands are attached. So that is the center of the clock, and hands are moving with some specific angle, right? With some specific angle. So here the rotation is nothing but we are going to change the position of the object along a circular path. So we are going to change the position of the object along the circular path. So what is the difference between translation and rotation then? The translation is taking place in a straight line. We are moving the object from one location to other in a straight line direction. But in case of rotation, we are changing the position of the object in a circular manner, where the angle of rotation is starting from 0 degree and it can have maximum value 360 degree. So it will complete a circle. So it will complete its path along the circle. So rotation is nothing but it is applied to an object by repositioning it along a circular path in XY plane. So here we are going to follow a circular path. And for that, always the point of rotation or the point about which the object is rotating is very important. So here we are going to consider the point of rotation as origin. So always remember this origin is acting as your point around which you are rotating the object. So the rotation is taking place with respect to origin. It will start rotating the object from 0 degree and it can complete the rotation up to 360 degree. So it will start rotation. The minimum angle of rotation is 0 degree. That means no change. And again, it can rotate up to 360 degree till this particular point. So that is how the rotation takes place. Now there are two ways of rotation. Either I can follow the anti-clockwise movement around this origin. Yeah, origin with respect to this origin, I am following the anti-clockwise movement. Anti-clockwise movement means opposite as that of your clock, right? So it is following the anti-clockwise movement. It is one type of rotation. And second is it is following the clockwise movement, right? So I will show it here. Okay. So what I have just said that your object will rotate by keeping origin as a center. So the object will move along this path. Like our moon is moving along the earth. So earth is considered as the center and around that the moon is revolving. In the similar way, the object which is in the XY plane, the 2D object will rotate along the origin. So whenever it is rotating in this manner, then it is called as anti-clockwise movement and it is considered always positive. Whenever we are having the anti-clockwise movement for rotation, then it is considered as positive direction movement. And when we are rotating the object in the clockwise direction, it is considered as negative. So always remember, when you are having the anti-clockwise movement, then it is considered as positive. When clockwise movement is there, we are going to consider it as a negative. Okay. So when I say rotate this object by 45 degree, rotate this object by 45 degree. So 45 degree means currently I am having this triangle which is parallel to x-axis. Okay. Then I will denote it with other color. 45 degree axis, that is nothing but your y equal to x line. So this is your y equal to x axis and it is your 45 degree line. Then when I want to rotate this object in a positive way, that is in anti-clockwise movement, then the object will come here, right? Because this angle is 45 degree. Similarly, the object should also form 45 degree with respect to origin. So this side which is parallel to x-axis will also become parallel to y equal to x-axis. And the remaining triangle will be like this. So this is nothing but you are going to have 45 degree rotation from its original location to new location. So here also displacement is taking place, right? Whether there is any change in the size and shape of the triangle? No, size and shape is not changing. Just you are rotating the object with 45 degree. So its location is changing, but how is the path of movement? The path is circular, right? In earlier translation method, if you remember, the translation is nothing but shifting the object from its original location to new location. So here the movement is in a linear manner, along a line. But here the movement is along the circular motion. So always the rotation is nothing but it is applied to an object by repositioning it along a circular path in XY plane. So repositioning of the object along a circular path in XY plane. Then to generate a rotation, we should have the angle. Am I audible?
Yes, ma'am.
Yeah, actually I got a message that connection is unstable. Okay, so while rotating the object, you should know the angle, by how much angle I should rotate my object, and that angle is represented always by theta. So theta is the angle of rotation, and the position XR and YR, they are the original position or the pivot point. Pivot point is nothing but the point on which the object is rotating. So that is called as rotation point or pivot point. And the position is represented as XR YR. So we are going to see this in detail, how the derivation is carried out for this rotation, 2D rotation. But for time being, you remember, for carrying out rotation, you need to get the angle theta, and you should know the original coordinates of the object. Okay. Then we have already discussed that positive values in counterclockwise or anti-clockwise direction. So in anti-clockwise direction, whenever we rotate the object, it is considered as positive. And when we use the clockwise movement, then it is considered as negative. So negative values rotate the object in the clockwise direction. So see here the example of the rotation. This is your original object, CG, this box, and with respect to origin, it is rotated. In which direction now? It is rotated in which direction?
Anti-clockwise.
Right. So it is rotated in anti-clockwise direction. So it is a positive way of rotation. So we are going to have the positive rotation along a pivot point, origin. So this point, origin, is acting as a pivot point or rotation point for this object. Okay. Okay. So next we will see rotation in detail. Okay. So the original coordinates of a point in polar coordinates are. So here we are going to take that earlier example which was represented. So I will draw that diagram here. Okay, so this is your original point P. with coordinates x and y. Okay, this is your original point P with coordinates x and y. Now my job is to rotate this point P to a new location P dash. So rotation of this point P to a new location. So we'll be rotating here and I will get its new location, that is your P dash with new coordinates x dash and y dash. Okay, with new coordinates x dash and y dash. Now this is my new point P, new point P dash along this circular path. Now this angle of rotation, let us say angle is theta, as we are knowing theta is the angle of rotation. Please bear with my handwriting. Okay, so this angle of rotation is theta. I will write here because that is very small portion. Okay, so now this is your angle theta with which you have rotated. Now this x and y values we will find out in terms of polar coordinates. Polar coordinates. So what is x and y? So x and y are nothing but, suppose I am going to draw a perpendicular on x and on y. Okay, so I have drawn this perpendiculars on x and y. So this is your x value and this is your y value. Now polar system means what? Polar coordinates, it is it has something to do with your angle. So here I will consider this angle of point P was phi. So this is, it is considered as psi. Okay, so this angle we are going to call it as a psi. So now can you tell me the value of this x in terms of angle? So for that purpose we will consider this is your origin with respect to which you are rotating the object, and the rotation is always carried out in a circular path. The rotation is always carried out in a circular path. So for circle, what is this OP? Radius. Right. Absolutely, you are correct. So in short, this OP is acting as a radius in this circular path, and I am having the radius value and I am having the angle of original P. Now can I get the x value in terms of R and this angle? Yes. So what is this?
R cos psi.
Right. R cos psi. So I am simply applying this angle is perpendicular and this 90-degree angle, this line is perpendicular. So what is the value of x I am getting? Simply I will write what is cos psi. What is cos psi? Cos psi is nothing but the side which is near to this angle, that is x divided by r. X divided by r. All of you agree with this? Cos of this angle is x divided by r. Right. So in short, I can write x is equal to r cos psi. By multiplying r in this side, I will get x is equal to r into cos psi. Similarly, what is sine of psi?
Y upon R. Y upon R.
Right. Psi of sine is equal to this value. What is this value then? Y intercept. So this is your y, opposite side divided by the r value. So here you are having y divided by r, and I can multiply r on this side and I will get y equal to r sine psi. So that is how we have calculated x and y in terms of polar coordinates. Okay. So once I get this, I can find out x dash and y dash in the same manner. I will use some other color. Okay. X dash and y dash. So x dash is what? Its perpendicular value on x axis and the perpendicular value on y axis. So this is your x dash and this is your y dash. Now can you tell me what is your x dash? X dash is equal to, now this x dash and y dash are with respect to this complete angle. And what this complete angle is? It is psi plus theta. Theta is our original angle of rotation. So psi plus theta is this complete angle. So I can say x dash can be calculated in terms of theta or psi plus theta. So I will say cos of psi plus theta. What is cos of psi plus theta? Cos of angle, cos of psi plus theta. Cos of psi plus theta, that is this angle. So a side which is closer to it divided by r. So r is going to remain same because it is acting as a radius only. So point is moving on the radius. So r is same. So what is cos psi plus theta is x dash divided by r. So x dash divided by r. So I will multiply it on this side and I will get x dash as r cos psi plus theta. So x dash is equal to r into cos psi plus theta. Similarly, sine of psi plus theta, sine of psi plus theta is opposite side, that is your y dash divided by r. So I will get sine theta plus, sorry, here by mistake it is written cos. Here it should be sine. Okay. So what is y dash? Y dash is r sine psi plus theta. So I am having the expansion of this bracket. So what is expansion of cos of angle addition? It is cos psi cos theta minus sin psi sin theta. So that is expansion I have written in this manner. Okay. So I will replace this r cos psi by x and r sin psi by y. Similarly, here also I will perform the replacement, and ultimately what I will get is x dash is equal to x cos theta minus y sin theta, and y dash is equal to x sin theta plus y cos theta. Okay. So here I will get the solution, that is x dash is totally dependent upon xy value and angle of rotation. Now there is no original angle of rotation is there in any of the corner. So in any of the expression, we are not having the term psi, but we are having the term theta only and xy values. So x dash is equal to x cos theta minus y sin theta, and y dash is equal to x sin theta plus y cos theta. So that we are going to write in terms of a matrix. So I will have, if I am writing x and y in a row, so if I want to get x dash y dash from xy, then I will write it in matrix form. So I will have here cos theta and minus sin theta over here. And here sin theta and cos theta. Okay. Now perform multiplication and check you are getting the same result or not. So x dash y dash is what? X cos theta minus y sin theta. Perform the multiplication row and column wise. So I will get x dash value as x cos theta minus y sin theta. That is our expression. And y dash is what? X into sin theta plus y into cos theta. X sin theta plus y cos theta. So when we carry out the anti-clockwise rotation, this is your matrix T, because our resultant matrix P dash is always equal to your original P into the translation matrix, transformation matrix. So P dash is equal to P into T. So this becomes your transformation matrix, which is totally dependent upon the angle of rotation. Right? Getting it? And when I want to carry out the clockwise movement, clockwise rotation, then this is the angle. This is the T matrix for it. So this sign is changing depending upon the rotation. So here it is in anti-clockwise manner, and for this T matrix is for the clockwise rotation. Getting it, all of you?
Yes, ma'am.
Yes. Is there any difficulty? Those who are not getting, they can ask me if they are stuck somewhere. Okay, so all these expressions and the final T matrix, all of you are getting. Okay, so I believe all of you are clear with this 2D rotation part. So simply what you have to do now is, if you want to check the new points or the resultant object, then that is equal to your original object into this T matrix. So you have to remember this T matrix anyhow: cos theta minus sin theta and sin theta cos theta. So theta is the angle of rotation. Okay, so let us see some problems on it. Shall I rub this part? All of you are clear about this, right? Okay. Okay. So the equation can be represented in matrix form like this: xy cos minus sin sin cos. This is your anti-clockwise movement, where this is your T matrix, that is transformation matrix. Now let us solve the problem on it. So point 4,3 is rotated counterclockwise by angle of 45 degree. Find the rotation matrix and the resultant point. So this point 4,3 is your original value P, that is xy, and theta is given as 45 degree, and the rotation is counterclockwise, that is this T matrix you have to use. So I will use this T matrix and get the solution. Okay. So what is R? R is cos theta minus sin theta cos theta, the same T matrix. Then replace theta by 45. So cos 45, sin 45 and all. So it becomes 1 by root 2, positive, positive, positive and negative over here. And then you have to multiply your original value 4, 3 with the T matrix, and then you will get the resultant P dash. So after performing the multiplication, I am able to get the result of P dash as 1 by root 2 and 7 by root 2. So that is your resultant point after rotation. Okay. So this is how we are going to solve the problem on 2D rotation. So I will give you one more problem on this. Consider the earlier example only with a triangle. So consider this example. The triangle ABC is given: A 10, 10, B 20, 10, C 15, 20. You have to rotate this triangle in clockwise movement with 30-degree rotation. You have to perform the rotation of the triangle by 30-degree in clockwise movement. So now it's your turn to find out the T matrix. So I will write here. What is your ABC given? ABC are having the values 10, 10, 20, 10 and 15, 20. So this is your P, original matrix. Now tell me T value. What is given in the problem? What is the angle of rotation given? Angle of rotation theta is considered as 30-degree, and the direction of rotation is clockwise, right? So whenever it is a clockwise movement, then minus sign comes over here. So this is your cos theta minus sin theta. Then here sin theta and cos theta. Okay. So this is your T matrix. Now put 30-degree in its appropriate location and find out the T. Till this particular point, is there any difficulty?
No, ma'am.
Okay. So what is cos 30?
Root 3 by 2.
Root 3 by 2, right? Here it is root 3 by 2. What is sine 30?
1
by 2.
1 by 2.
1 by 2.
Right. So minus sign will come here. Then again here it is 1 by 2 and root 3 by 2. So I will multiply this p with t and I will get my resultant value p dash. So I will write over here. So what is the solution you are going to get is 10 into root 3 by 2 plus 10 into 1 by 2. So 5,
5 plus 5 root 3.
yes, 5 plus 5 root 3. Similarly, 10, this row and the second column. So this is minus 5 by minus 5 and
Minus 5 plus 5 root 3.
right, minus 5 plus 5 root 3. Then 20 in the same manner. So I will get 10,
10 root 3 plus 5.
yes, 10 root 3 plus 5. And here minus 10 plus 5 root 3. Okay. Next is 15 into root 3 by 2. So 15 root 3 by 2
Plus 10.
plus 10. And here minus 15 by 2
Plus 10 root
plus
3.
10 root 3. Right. So this is the ultimate, that is resultant triangle P dash that we are going to get after rotation. Okay. So its diagrammatic representation will be with respect to origin. The current value is 10, 10, 20, 10. This is your 10. This is your 20, let us assume. So 10 and 20. And this is your 15 value. So this is your triangle. And the clockwise movement of this will change the angle of rotation by 30 degrees. So this is your 30-degree angle with respect to origin. So I will draw it with some other color. So this point, it is your A point. It gets rotated by 30 degree. And this is your 30-degree rotation. It will come somewhere over here. Then B point is here. Then B point will also rotate with 30 degree. It will come somewhere over here. And the C point currently at this angle, it will rotate with 30 degree and it will come somewhere over here. So after rotation, I will get the object like this. So this angle of rotation is 30 degree. Getting it, all of you? You can convert these values in float numbers so that you can come to know about. And obviously this triangle is correct because this triangle is having all y values negative and it is towards your negative y-axis. So it has to be in the fourth quadrant, right? All of you agree with this, that x is positive. All these x values are positive and all the y values are negative. So it has to be in the fourth quadrant by performing the rotation with 30 degree with respect to origin. Okay. Getting it?
Yes,
Yes,
ma'am.
ma'am.
Yes. Is there anyone who has not understood what is done in this multiplication? What is done in this rotation problem?
Hello, ma'am.
Yes.
Ma'am, in that figure, which angle is 30?
Okay. I will represent it with green color. So this angle is 30. Because this is your C, point C, right? A, B, and C. This is your A point, this is your B point, and this is your C point. After this 30 degree rotation, C will get shifted here, that is your C dash. Then point A is currently at this particular point. A will also rotate with 30 degree and it will get shifted to this new point, that is A dash. And B line with respect to origin is here. So this point will also rotate with 30 degree and it will be shifted at the location of B dash. So ultimately each and every point on this triangle is going to rotate by 30 degree. So you are going to have each and every point rotation, but I am focusing only on the 3 vertices for simplicity. Otherwise every point is rotating with 30 degree with respect to origin. Getting it now?
Yes, ma'am.
Yeah. Okay. In the chat, is there any question? No. Okay. So that is how the rotation is carried out in clockwise and anti-clockwise. So you have to remember this T matrix. So remember it with it for only anti-clockwise, minus sign is here. Then you will always remember when we replace these two or exchange these two values, it will be the T matrix for clockwise direction movement. Okay. So always remember only one T matrix and you can find out the other one by just exchanging these two fields. Okay. Right. So let us move to the next bit. Okay. So next is very interesting transformation of 2D image that is called as scaling. So scaling, it's same. Scaling is the phenomenon which is impacting the size of the object. Till now, the two transformations that we have studied was the translation and rotation. They have nothing to do with the shape and size of the object. Right? Simply, they are changing the position of the object. But now scaling deals with the size and shape of the object. So scaling is nothing but it is a transformation which alters the size of the object. So here the size of the object will be changing. So this operation can be carried out for polygons by multiplying the coordinate values x and y of each vertex by scaling factor sx and sy. So Sx is nothing but the scaling factor along x-axis or for x coordinate, and Sy is the scaling factor for y coordinate, which will produce the coordinates, which will transform the resultant coordinates as x dash and y dash. So as usual, our original values are xy, your new values are x dash and y dash, and they are having the scaling factors Sx and Sy, right? So the formula will become x dash is equal to x into Sx, y dash is equal to y into Sy. So Sx is nothing but scaling of the object in x direction. Sy is scaling the object in y direction. So what is the meaning of this? That I will show you. I will show now only the first quadrant for simplicity. Now consider this is my given triangle. This is the given object. Okay. This is the given object. Now, if I want to enlarge the size of the object in x direction only, and y direction, or in y direction, I want to keep the object as it is, right? That means I want to change it along x-axis, but y should be as it is. Then what will happen? If I want to keep y as it is, what should be the value of Sy? Am I audible? Hello? Am I audible? Students? Am I audible now?
Yes, ma'am.
Okay.
Yes, ma'am.
It was net get disconnected. Okay. Okay. So scaling means what? Just now I have drawn one diagram, and scaling is changing the size in x and y direction. So this was the triangle I have drawn earlier. And now my requirement is I want to change the size of the object only along x-axis, and along y-axis I want to keep the object as it is. Along y-axis I want to keep the object as it is. So what should be the value of Sy then? Along y, I don't want any change. So y should remain as it is. Y dash is equal to y. So what should be Sy then? Sy should become 1. Right? So that when I multiply y with 1, there will be no change. And I want to expand it along x-axis. So expansion means what? If this value of Sx is greater than 1. So when Sx is greater than 1, then only expansion will take place. Otherwise, what will happen if Sx is less than 1? Suppose Sx is 0.5. 0.5. Then what will happen? X will become half. X will become half. So it will be a reduction. But when I want to expand, it, then am I still audible?
Yes, ma'am, audible.
Okay. So when I want to expand it, Sx should be greater than 1. So what will happen? The y value will remain same. Only x is changing. So x is expanding. So what happened? Here the height of the triangle is not changing. Only the width of the triangle is changing. So it is nothing but your expansion along x-axis. So scaling factor Sx scales the object in x direction as we have done here. And in opposite way, if I want to scale the object in y direction, then what will happen? Here the width will remain same and the height will change. This is not the correct one. I will show you the other one. Yes. So if I want to scale this object, then what will happen? Here the x values will remain same. X is what? These two plus this value. So x will remain same, only y will be changing. Okay. So what is happening? X of this particular point is same as that of x of this vertex. Similarly, x of this point is same. There is no change in the x, but height has been changed. So we are changing the y, changing the object in y direction, expanding the object in y direction. That is called as y expansion, where sy plays important role. And this is your expansion in x direction, where sx plays important role. Okay. So that is how the scaling is taking place. So in scaling, actually the size of the object changes. It can expand as well as it can compress also. So you can compress the size also. So that is again one of the scaling only. So here this scaling is dependent upon Sx and Sy values. So if Sx and Sy both are 1, then what will happen? Sx is also 1 and Sy is also 1. Yes.
Unchanged size.
Huh? Yes.
Same size.
Yes. So when Sx and Sy both are same, that means x dash is equal to x and y dash is equal to y. So there will not be any change in the original object. Okay. So that is how the scaling takes place. Now next points we will see, that is any positive numeric values can assign to the scaling factor Sx and Sy. So you can have Sx and Sy, any values will be there for them. When the values are less than 1, just now we have seen, when Sx and Sy are less than 1, what will happen? Your size of the object will reduce. So compression will take place. Right? So whenever the object is less, whenever this, yes, mute yourself.
ते हा सापडतं एक पीडीएफ आहे त्यात सापडतं पण पासवर्ड मग आपल्याला ट्राय अँड एरर मेथडने यूज करावा लागतो.
Students, mute yourself. Then when the values, that is Sx and Sy, are less than 1, reduction or compression takes place. And when Sx and Sy are greater than 1, then we are performing the expansion of the object or enlargement of the object. When both values are 1, then size remain unchanged. Okay. So these are the factors, how they affect on the size. These factors, depending upon their values, how they affect on the size of the object. Similarly, when Sx and Sy are same, they are equal. When Sx is equal to Sy. So what will happen? When both are same, equal, then same amount of size change is observed along x and along y. Along x and along y, the same size change is observed, and that is called as uniform scaling. Uniformly, I am changing along x and along y. And when the unequal values are there, when Sx and Sy are not same, then this kind of thing, Either you can expand it on X or you can expand it on Y or even compress it on any one of them. So there it is called as differential or non-uniform scaling. Okay, getting up to this?
Yes, ma'am.
Right. So we will stop here for today. Thank you.